Well, we had another interesting story that we covered this week that appeared in the Wednesday issue of Quality Digest Daily. Lower production costs with non-destructive radiography.
Radiography, that's right.
That's right. Written by Mike Forbes of TUV Rheinland Industrial Solutions, and I think that we probably have that up on our screen share if you want to show that so that the people can take a look at that. Interesting, because this really looked at this from a lean perspective and how organizations, particularly manufacturers, look at sorting and containment and problems that might pop up with components in many cases.
Sure.
And how you handle that, whether you do it upstream, downstream, what the cost structures are. So we have Mike Forbes with us from TUV Rheinland Industrial Solutions. Mike, are you there?
Yes, I am. And by the way, I do love my job.
You do love your job.
As do we.
You're not one of those cranky guys, are you?
No, not at all.
All right.
We have fun here. We have fun solving problems for our customers, that's for sure.
Well, I guess that's what we're going to talk a little bit about today is one particular way of problem solving.
We are, and we'd love to start off and kind of talk a little bit about radiography, and there's some different angles, some different elements of radiography that you talked about in your piece. And tell us a little bit about what radiography really is and how it helps manufacturers ensure quality.
Yes, radiography is a good method. It's not save all, but radiography is a good method where we can look at a part and find interior flaws or defects, missing components, things like that, in order to find problems and sort the product out, good product from bad product, so that we can basically continue the service and that we can the customer can provide good product to the end user. And so basically what we do is we use different methods like real-time fluoroscopy, looking at the part as it moves across down a conveyor system, sorting a bunch of product to looking for particular areas of interest and finding defects. And then we can use digital radiography in the field or in the laboratory environment. We also have computed radiography, which uses a phosphor plate. Again, very good method to look for defects and also to transmit the data via the internet. So there's a standard X-ray that we use also, and gamma radiography. All these methods we use in different areas to help our customers with their areas of interest or problems.
Well, let's talk about that, Mike, and let's look at what a potential problem might be. Let's say that I'm an automotive manufacturer and I'm in the process of some assembly, and I see that there's a problem with a component or a part from somewhere in my supply chain. Well, what would I do? How would I use the TÜV Rheinland Industrial Solutions services to handle that?
Well, basically, it'd start with the phone call and saying, "Hey, I've got this particular problem. Is it a method? Is there a method I can use to feasibly find or sort this flaw or this indication?" And basically, what we would do is we would take and put it in front of our technical team, and we'd say, "Okay, yeah, radiography, fluoroscopy is probably a good method. It can detect this area of interest, and we can basically see the defect, and we prove the process, and basically we'll start, giving them an estimate." Now that process might be going to their facility in the field, or it might be sending the components to our laboratory here, depending on location, logistics, and cost.
And what kind of things might you be looking for? I mean, give us an example of something maybe you did on site rather than being sent to a TUV lab, where you set up something on site to look for a particular type of problem. Describe what one of those might have been.
Okay, basically welded components. We might have a flawed weld that we're looking for a defect or an area that it wasn't complete fusion or something like that. So we'd take the mobile rigs and we'd go to that location and look at the particular welds. We've done that in the bridge industry, and we've done it in the automotive industry. There's just particular areas where that can be the most cost effective, where we can take a, either an X-ray tube or a gamma source and go out there to the location, and or if it's in service or if it's on the vehicle or things like that where we have to utilize the X-ray, that would be one of the methods that we would do.
Now, is part of what's going on here is that you talk about weld inspection, but I think before you've talked to us about being able to maybe look at a circuit board or look inside an assembled, some sort of assembled device. It's faster to X-ray it than it is to, take it apart and do a visual inspection?
Yes, like like you said, electrical component. Sometimes in a switch, a wire gets pinched, or there's a missing component, and basically through the proper location of film to source, you can basically visually see the missing component, or say, yeah, this one is correct, or this wire's pinched, or this wire's misaligned, or the spring is out of alignment. Therefore, we're going to have a potential problem here. We can sort, move on, and say, okay, this one's good, next, and et cetera, et cetera. Mm-hmm. Move on down the production line, basically.
And it's interesting because really this is in many cases, this is a situation where you're going to deal with this pretty far downstream. I mean, many times what happens is we come to this when the problem already exists. How do you push it upstream a little bit, and how do you make sure that you're able to save a little bit of money and time maybe by catching it earlier in the process?
Yeah, a lot of times, people with like prototyping and stuff like that utilize it for a method. Is you take a look and say, okay, how does my component or how does this product look after the, your PPAPs or your first runs, and you start taking a look at them using radiography or the proper method, and all of a sudden you might find potential problems with the product. But the other thing is you can see that your product is good, and you're not going to have as many defects or potential problems down the road. So I would suggest, the method of moving it up would probably save money down the road, basically by finding areas that could become potential problems through looking at it through X-ray.
We know your organization. We know TUV obviously well, as many of our readers do, as basically as a registrar, as a certification company. So it's interesting to talk to you a little bit about this from a product perspective and an inspection perspective. How did your group get into this space?
Basically, TUV has been a registrar for quite some time, and a lot of their satisfied and prospective customers were looking for material testing services, and basically they, with part of their strategy was to deepen its industrial services business globally. So basically they approached us, and it's been a real good fit because it also has given us the ability to expand our services and to approach new markets that were previously, for a small company, were out of reach. Mm-hmm. So basically the strength and core quality values of each company has really become a benefit to both of us.
Great. Well, radiographic testing, really very important system for testing non-destructively, and looking at certainly the supply chain, looking at different parts and components of manufacturing.
Right, and I think the important thing, and you guys talked about that a little bit, is that kind of what we've been talking about here mostly is reactive. Mm-hmm. Ideally, you wouldn't be doing this inspection
after it was a problem already.
After you found a problem.
Sure.
Ideally, you could move it up further in the supply chain using the same technology. I mean, there's no reason radiographic testing couldn't be done as a part is received into the country, if it's coming from overseas, or even as it's leaving the manufacturer of the part or whatever.
Wherever it may be. I assume that's correct, Mike, or that this is just as easily utilized at a supplier plant before the shipment goes out as anywhere else.
Yeah, exactly. Radiography has come a long ways in the last few years. There's kind of been a phobia about the radioactivity and things like that, and then with the new technology out there, and it's become much safer, and it's become much more basically readily available. I mean, to utilize as an inspection tool, and handled with the proper certified individuals and with the proper equipment, it can do volumes of cost savings for the customers.
That's great. Well, hey, Mike, we're going to leave it off there. Thank you for joining us. Mike Forbes, again, everyone, National Sales Manager for TÜV Rheinland Industrial Solutions, joining us here today in QDL, talking a little bit about radiography inspection for sorting and containment. So thanks, Mike, for joining us. Good segment.
Thank you for the opportunity. I appreciate it.
Thanks.
Sure, no problem.